Hello everyone, I'm Xiaogam. We actually executed it on our end, but it doesn't seem to have achieved the desired effect. I noticed that some parts might have been missed or written incorrectly. Let's check now if there are any places that were written incorrectly. You can see that something is definitely wrong on our end. You can see here that after we set a breakpoint and step into it, there is an issue. Let's set a breakpoint. You can see that the task here is problematic. We didn't perform the tentacle drawing. Right. Didn't perform the tentacle drawing. So this ID is problematic. See, although it already has them here, these 10 tasks, let's step into it. Let's check this pointer again. You can see it has 10 tasks. Now it has 2. Then we execute it. We go to this place. After execution, right. Then go down. Then we check this task pointer. You see, ignore this part for now. Let's jump directly into the tick. This is another thread. We won't worry about what's happening in other threads. You see, it has already jumped to the foreground thread. We are mainly inside of the tick. We found that the logic here is problematic. Actually, it has already executed successfully here. It enters here. This place goes back to the main county town. We'll ignore it. Let's go back to the tick. We mainly look at this part. You can see here there are 10 tasks. Yes, this ID is wrong. If we haven't made a mistake, the belong tasket of these 10 tasks is like this. Their status is actually successful. Right? They are all successful. But then here, it's right here. You can see we go down here. We can see, well, after this executes, here it is empty. It actually does not. It did not execute successfully here. Then the logic here might have a problem. Let's fix the previous one first. This GUID was not initialized on our end. It should have been missed. So here, we need to initialize the struct here. And then here, it's masked is fine like this. And then this mask studios. We need to do a simple initialization. Obviously, for this message status, we just need to give it a launch status. Then this message, we give it a long with no information. Okay, now let's check again. Actually, we mainly need to check this tick. You'll see it's like this. You'll see that after we click, it gets stuck on this frame. This proves that in this tick, the callback logic was not executed correctly. Then observe this place. You'll see that our task number, you'll see that everything inside has already succeeded. You'll see. So if you click on each one, they are all successful. You see its statuses are all successful. But there is one problem, which is this state, this method, this value, it executes the check many status. This method, it returns a possessing. Then that is not correct. You see, in this case, if it is not equal, only when it equals lone will it return this possessing state. So obviously this is wrong here. Yes, then as for this state, we can check what the reason for this is. Let me set a breakpoint and check. This reason is also found because we didn't preset this state here. Actually, as long as it was previously. If what was returned before was this, it will keep returning this, right? So if we fix this part, it's actually very simple because it works like this at the very beginning. It must be in the possessing state, but you didn't notice. We didn't give it a successful state. So regarding this part, it's still a problem of sudden death. You could just give it a success from the start or handle it in some other way, but we need to handle it like this. We'll do it right here. We give it a preset state. We'll directly preset it to success. That should be fine. Then, let's take a look. Many status. Not this one. This one is success. Okay, as long as it's preset to success, it's fine. But actually, there will be a problem here. Just be sure to pay attention. If this quantity is not equal to this, right here, if the two quantities are not equal, we just directly make it return the possessing state. It means it might not have been fully added yet, because this task might be reversed. You see, we set it to this state. Then we need to return. Yes, just return it. then doing it this way should be fine. Now let's take another look. Okay, let's execute it now. Okay, this is when he first enters. It must be in the processing state, right? Since we have a ready-made sleep here, we'll just pass it through. Okay, and you can see it has finished executing now. You can see these are their respective execution states. You can see all 10 tasks executed successfully. No issues at all. You see, it took us about a few dozen frames to execute at around 40 to 50 frames per second, and then it executed successfully in the end. No problem at all. So now, for example, we have a task that failed, right? Then we can take a look. We can modify this kind of macro, this macro approach. Yes, look at that engine. It really likes to use this macro approach to define things, to toggle certain features on and off. And actually, you can also write code using macros. We'll supplement this for everyone later. The matter of writing code using macros. Okay, let's start here. You can see for this place has already failed. You can see it failed, right? And here there is a very long day. Failed. That is, it failed. Our first is that we failed when initializing I, etc. Just now, you will find that the process has been cancelled. This place is still equivalent to a failure, right? Take a look. Then here, for initialization, because we failed, it seems no traceability work was done here. It is already seen that it is here. Because our failure this time is in this init. Superior information here. Failed here. It failed here. Here, if cancel slow is triggered, we need to release some support. What support do we need to release? It should be mainly releasing these two supports. We are here. Release it. And now let's start. And now let's start it. We are with him on the date. You can see now it has failed. Right, this is the blueprint we printed out. Received this log. Let's click it again. You can see it failed again. No problem at all. Okay, so actually our counterfloat is very powerful, but we only covered a little bit. And you might think this code is a bit complex. You see, we haven't written any actual functionality. And just like that, we've written 400 or 500 lines of code, but it's really useful. And here we'll add some more information for you. For example, right here, in this initialization story, we can write code like this. You can get a feel for it. Take a look. It should be like this. Like this. Put this here. Okay, then we can write a registration here. That won't work either. No problem. And this kind of code is very interesting. So if we enable this, we'll just add a log for it. Was this covered earlier or not? It might not have been covered. This is a practical little tip. Because the engine, it often works this way. Here we give this L. Just give a warning here. Give for txt. Normal initialization flow. No failure in the original state. Okay, then here, if we can also have an else here. For example, we should be able to have an else here. And here, under if should be under if. Okay, right, that's correct, right? Okay, this initialization process has failed this time. Okay, so now we are giving this, I want to try if we give it 0. So it's 0, 0 means it goes to the one below, which means there is a failure. Okay, so we can take a look at what the log he printed looks like. This should be knowledge from C, C++. Yes, but Unreal. Unreal often writes it this way. we can see, hey, see the initialization process. This time there is a failure, right? Completely, no problem at all. Okay, so it's very obvious to you. You change this place to 1. He left this place. Then this thing, most of the time, we don't write code like this. Most of the time, we don't write it like this. But sometimes, in some special cases, we do write it like this. Because once you write code like this, then when you collaborate with others, you must mark it clearly. In our project, what documents are there? Which interfaces? Which part controls it? Otherwise, you can just pick any header file. You can see we have so many header files. I define it here. This thing. How would I know what this thing is supposed to be at any given time? What is this 0? What is 1? What is 2? Even the developer might forget it themselves. So generally, you don't write it this way. This chapter will demonstrate for you. Okay, this chapter we have finished explaining. The last 2 subsections, the code of these 2 or 3 subsections is actually quite difficult. It has a certain level of difficulty, and in actual commercial processes, most of the time it is at. Basically, this level of difficulty should be about the same as this. Basically, you can, at this level, wrap it up a bit more. According to the specific scenario, wrap and modify it a bit more. Just use it like this. There is basically no problem at all. That concludes this recent lesson, and thank you everyone.